In this demonstration, you'll learn how to set up a static structural simulation to study the results of pressure loading on a curved pipe. I'll start by selecting a simulation process template from the study panel on the left here. I'm going to select the structural template. I'll select the option to define new geometry. I am running a pure structural simulation, so I won't select another physics type. I can either do a static analysis or a modal analysis. For this example, I'll select a static analysis and accept the default selection for the options list so that contacts in the interface of the bodies are detected automatically. I will then apply the template and create the simulation process. AIM has automatically created the physics solution process, which involves the geometry import, meshing, physics, and results. Here is a summary of all of the tasks created along with their status. All of these tasks are also available in the workflow window in a data flow diagram format. In creating my simulation process, the first thing that I'm asked to do is define my geometry, so I'll select the geometry task. There, I'll choose to import a geometry file. I'll select the geometry for this curved three-part pipe. AIM will now load the geometry and apply additional tasks that are part of template setup. Because the meshing task has all of the information it needs to produce the mesh, I'll go ahead and update it now. The meshing task is now complete. My physics solution task, the red exclamation mark here, is telling me that it needs more information added in order to complete the simulation. I'll click on it to go into this task. You'll see that a lot of defaults have already been set up for me: material assignments, physics options, interface conditions, and solver settings. You can also see that an interface generator has been created, and contacts will be generated when this task is updated. The blue button shows the actions that still require attention. Here, I need to add some boundary conditions. First, I'm going to add a displacement boundary condition. I'll use the face selection filter to select the face at each end of the pipe. Then, I'll add a displacement boundary condition from the context menu. The boundary condition is now up to date. Next, I want to apply a pressure to the inner curved faces of all the three bodies. I'll start by selecting the three outer faces and hiding them. Now I'll select the inner curved faces of all of the three bodies. Then I'll right-click to add a pressure boundary condition. I'll set the pressure and then press Enter. You can see the magnitude value is also reflected here in the pressure panel. The pressure boundary condition is now up to date, and with those few additional settings, my physics solution is all set up. Before proceeding, I'll want to show all bodies again. And then I'll solve the physics solution task. I can see the progress on the bottom right-hand side here. Everything's updated, so now I can view my results. I'll click on the Results task, and then Evaluate. I can then expand the Results heading to view the predefined results. One predefined result shows the displacement of the pipe under the load. I can also use this pull-down at the top to select my other results. I've got equivalent stress here. And, if I like, I can right-click on the screen and animate my results. I can also add the force reaction result to view the reactions generated at the two fixed ends of the pipe. I'll right-click and add that result. Then I can evaluate and view the force reaction. This concludes this demonstration of an end-to-end basic static structural simulation in AIM.